Okay, so today we're going to continue our conversation about ions. So we're going to just start up here. Ions are charged particles. We talked a little bit yesterday about why they become charged particles, and we'll kind of review that here in a little bit. But we are going to differentiate ions into two groups today. We're going to start with cations and anions. And these guys are kind of equal and opposite. Okay, cations are positive. I remember that. It's easy to remember that because cats have paws, so they're positive. I know, cheesy, but cations are positive. So if cations are positive and anions are opposite, anions are negative. Okay. Cations form from metals, so anions form from nonmetals. Okay. Cations will lose electrons, so what are anions going to do? They're going to gain electrons. Alright, so let's kind of draw our famous scribbled in periodic table, just so we can take some notes on it, and we'll go back to the real periodic table. It's lovely, right? We'll go back to the real periodic table here in a second and note that. But we're going to we have boron, carbon, nitrogen, oxygen, fluorine, and then the noble gases. Right? So when we look at cations versus anions, cations form from metals. So cations are actually going to include some of the metalloids as well. Alright, cations are going to be all of this part of the periodic table. Okay? Anions are nonmetals, so they are going to be this part of the periodic table. Notice that I left out carbon and silicon right there. Carbon and silicon do not normally form ions. Okay? Why did I also leave out the noble gases? Noble gases do not form ions. Noble gases do not form bonds under normal circumstances. So we should probably go ahead and make a note of that. We're going to put normally, because there's to say all, any exclusive statements, right, in science. So let's consider some of the things on the periodic table, some of the elements that we have. We know that lithium is right here. Okay. Lithium has one valence electron. So is lithium going to gain 7 more, or is it going to lose that one? It's going to lose that electron. When lithium loses that electron, it's going to give it a +1 charge. This is another example of where families all behave the same. So everyone in this first family is going to form +1 ions. Right? Well, let's look at beryllium, which is right next to lithium. Okay? Beryllium has 2 valence electrons. Is it going to lose those 2, or is it going to gain 6 more? It's going to lose those 2. And when we lose those 2 electrons, we're going to have a +2 charge. Now, transition metals we will talk about later. They're complicated, they don't play nice, and you have to look all the way through the electron configuration to really understand. So we'll get to that in a minute. But boron, let's go ahead and look at boron. Okay. boron has 3 valence electrons. Is it going to lose those 3, or is it going to gain 5 more? Well, it's going to lose those 3 because it only has 3 to make bonds with. It can't gain 5 more. It doesn't have any faculties to do that. So boron is going to make a +3 charge. All right. So we'll also, let's go ahead and consider, we'll just keep considering nitrogen. Okay. Nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. Is it going to lose all 5 of those, or is it going to gain 3 to fill in its octet? Well, nitrogen is going to gain 3. And if it gains 3 electrons, it has 3 more negative things in it, it's going to make a -3 charge. Oxygen is going to make a -2, and fluorine is going to make a -1 because it just needs 1 electron to fill up its octet. And then it would look like the noble gas configuration that we want it to look like. Alright. Let's look at this bond right here. If we made a bond between boron and nitrogen, okay, boron would take on a +3 charge, and nitrogen would take on a -3 charge. So when we think about this molecule as one thing, we would have +3 plus -3 as an ionic bond. The overall atom, the overall molecule, would have a neutral charge. So that's more stable. That causes stability. Do you know of some elements, some molecules that have stability? Oh, yeah, you do. Of course you do. We have H2O. That's one everybody knows. Everybody knows that one. How many H's do we have? You have 2 H's. What ion does hydrogen form? If you look back at our little notes, hydrogen's in the first family. It's going to make a +1 ion. Let me manage my stuff here. Make a +1 ion. What does oxygen make? Oxygen makes a -2 ion. So if we add this up, +2 plus -2, we get a neutral charge. Now, how do you know the subscript? How do you know that subscript? Well, that is where our crisscross method is going to come into play. So let's, we'll do that in our practice here in just a little bit. Let's see. But let's go back and talk about these cations here in the transition metals. We're going to talk about iron, right? Iron. So remember we said transition metals don't really play nice. Iron has 26 electrons because that's its atomic number, okay? When iron has a neutral charge, its electron configuration looks like this. Argon, 4s2, 3d6. Small problem. 4 is a higher energy level than 3. So iron can lose these 2 electrons. And so iron with a +2 charge looks like this. Iron can also make a +3. Well, now hold on. How does that work? Well, let's go back and consider the +2 ion, the cation here. If we look at this D sublevel, in the D sublevel, we do the orbital drawing. We're going to have 5 boxes, right? If I have 6 electrons, I'm going to have 1, 2, 3, 4, 5. We'll just go down here. 6. That is not stable. That is unbalanced. So iron will go ahead and lose this electron as well. And so, because that gives it a half full orbitals, half full sublevels are more stable than unbalanced sublevels. So its electron configuration would look like that. Now, you can go through all that business and try to find which ones are half full and make it work, or you can reference the sheet that you were given. The picture that was in the lesson from today that kind of gives all of the charges for the transition metals. But it's important to know that those transition metals can have more than one ion. So iron, copper, zinc, a lot of them have more than one ion, and so you need to understand the why behind it. Okay? All right, so that is it for today. We will do some crisscross method tomorrow. Okay?